Hello everyone, this is Mr. Avila with our videos here helping my Algebra 2 students get ready for their Unit 1 exam on sequences. This is question number 7. Here are two sequences. Sequence A, written in table form. Sequence B, written in the form of a graph. For sequence, and we're being asked, for sequence A, describe a way to produce each new term from the previous term and write the definition for the nth term. That means we're being asked to find the recursive form and the explicit form for the sequence in this table. Now in this table I have a zero term as -6, -2, 2, 6, and 10. Okay, just reading these numbers off. Now we do notice that the first term is stated as 0, but the sequence is still going to be in the same order. Now, is this sequence arithmetic, geometric, or neither? Starting at -6, then I go up to -2, up to 2, up to 6, up to 10. If you struggle with the negatives, maybe start here, and I notice that 2 plus 4 is 6, and 6 plus 4 is 10. Seems like it's arithmetic as we're adding 4 every time, and it is true. -6 plus 4 is -2, and -2 plus 4 is 2. So it is arithmetic. Let's write the recursive form for this arithmetic sequence. Our first term, which we're going to start it at 0, just because we got the number 0 right there, is -6. And then our recursive form would be current term is previous term, and then the rule. So here it would be current term, f of n, is previous term, and then the rule is plus 4 here every time. Okay? And now for the explicit version of this same sequence, we're going to remember, since it's arithmetic, we're going to use the arithmetic formula for this function. And that is f of n is equal to first term plus growth rate times n minus 1. In this case, we're going to write here current term here. This is the explicit form. Current term is first term, -6, plus the growth rate, which we're adding 4 every time, times n minus 1. This over here is going to be the explicit form. Moving on to part B. Now part B is going to ask about sequence B. For sequence B, describe a way to produce each new term from the previous term and write the definition for the nth term. Again, we're being asked to find this sequence recursively and explicitly. But what's the sequence? Now here we have an interesting situation. We have a graph. At 0, there is a dot there. It's right in between the 0 and the 2. This would be 1. Let me write the sequence up here. So the sequence B is going to start at 1, again from right here. The first term, looking at the 1, I'm going to go up to see where it lines up. That point lines up at 2. Second term is 2. Third term lines up right there with the 8. Fourth term lines up right there with the 16. Fifth term, lines up right there with the 32. So what type of sequence do we have there for sequence B? 1, 2, 8, 16, 32. They are getting bigger, but they seem to be getting bigger faster. I'm guessing it's going to be geometric, and 1 times 2 is 2. 2 times 2, I missed the term there. 2 times 2 is 4. I actually skipped the term. Let's kind of recap that. So at 1, the sequence was at 2. At 2, the sequence was at 4, so I missed the term there. At 3, the sequence is at 8. At 4, the sequence is at 16. And at 5, the sequence is at 32. So I jumped the term there. And so now does my rule work of multiplying by 2? 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, etc., etc. We have a geometric sequence that starts at 1. So now let's write the nth term, the recursive and explicit form. For the recursive form, we're going to start at 0 here. And the first term right there at 0, because it starts here at 0, is 1. I'll put a 1 here. Then we're going to write the rule for this, and that is current term is previous term times 2, because we're multiplying by 2 every time. This is the recursive form. For the explicit form, I'm going to think to myself, what was the formula for a geometric, explicit form geometric sequence, which was f of n is equal to first term times growth factor to the power of n minus 1. So our explicit form for this geometric sequence would be f of n is equal to first term, which is 1, times 2, which is the growth rate, because we're multiplying by 2 every single time, to the power of n minus 1. And we'll have our growth rate. By the way, that's a 2 right there. Class, if these sequences were to continue, which is going to be greater faster? A of 7, so the seventh term of A or the seventh term of B. Which one would be bigger? Now, if I were to, this one's only adding 4 every time. Like if I were to go, this is the fifth term. So if I were to add 4 2 more times, that would be 14, 18. This would be at 18. The fifth term of this is already at 32. So if I went to the seventh term, the sixth term would be 64. The seventh term would be 128. The seventh term of B would be much bigger than A. So I would say B of 7 is bigger. And then I would need to add some kind of justification. So I would say something like B grows faster. Something along those lines. Or maybe B grows faster, or B is multiplying by 2, and A is only adding 4. Some type of explanation that you could tell me, why is it that you could tell that B was growing much faster than A? Class, let me know if you have any questions here on question number 7. Thank you for paying attention to these videos. Hopefully it helps. Good luck on your test, and I guess I'll see you then. Bye.